Good morning, students. So this is Rajshekhar, mathematics faculty. So today we discuss the topic, the probability, which is the one of the important topic for Eamcet. From this chapter, we will get 2 to 3 marks. Okay. First of all, in this chapter, we'll study about the mathematical understanding of chances. First of all, we'll learn about the random experiment. Random experiment. An experiment is called a random experiment if it satisfies the following conditions. Number one is the possible outcomes should be more than one. That means, suppose in tossing a coin, the possible outcomes are two. What are those? Head and tail. One is head and other one is tail. So here we have more than one outcome. So that is one is head and tail. So and the second condition is the possible outcomes are The possible outcomes are unpredictable. That is, we cannot the exact outcome, the accurate outcome of the experiment. So that's why. So see here, in tossing the coin, the possible outcomes are head and tail, but we cannot guess the what is the exact outcome. What is the exact outcome? Either we can get either head or tail. That's why that is called random experiment. That is called random experiment. So that means the the outcomes we cannot predict the possible outcome. The possible outcome. So now sample space. The set of the set of the set of all possible outcomes, all possible outcomes, the set of all possible outcomes in a random experiment is called sample space. Sample space, and it is denoted by capital S. It is denoted by S. So see here, for example, in tossing a coin, in tossing a coin, in tossing a coin, so the possible outcomes are possible outcomes are head or tail. Tail. That is S is equal to H comma T. So here H is the head and T, capital T denotes the tail. So you can see another example. In rolling a die, in rolling a dice, the possible outcomes are 1, 2, 3, 4, 5, 6. So here the sample space S is 1, comma 2, comma 3, comma 4, 5, 6. So this is the sample space. This is the sample space. Now, next is event. Next is event. An outcome, an outcome or a result in a random experiment is called an event. Is called an event. So, for example, example, in rolling a die, suppose in rolling a dice, in rolling a dice, rolling a dice, we can define an event like getting an even number. So let E is equal to getting an even number. This is an event. Getting an even number is an event that is denoted by capital E. So this here, some important point is any event can be denoted by capital alphabet that is A, B, C, and so on. So any event can be denoted by capital alphabet A, B, C, etc. So we have different types of events. Different types of events. So the first one is mutually exclusive events. Mutually exclusive events. So all the events, if all the events of a random experiment are said to be mutually exclusive, mutually exclusive if the occurrence of or happening happening of one event will prevent the will prevent will prevents the occurrence of prevents the occurrence of remaining all other events remaining all other events. So remaining all other events. For example, for example, let in tossing a in tossing a coin let A is equal to getting A is the event, getting A head, and B is another event, getting a tail. Getting a tail. See here, if happening of event A, here the happening of event A will prevent the happening of the event B. That is that is that is A intersection B is equal to a null set. That means A and B have no common elements. A and B have no common elements. Suppose if A1, A2, A3, and so on, AN are the N mutually are the N mutually exclusive events of a random experiment then A1 intersection A2 intersection A3 intersection and so on intersection AN is equal to null set. So this is the mutually exclusive events. These are the mutually exclusive events. So now next is, so first of all we go through the concept, then we will start doing the problems. Okay. So first of all, we have to know about what is the concept, what is the probability, and so what are the events, how many types of events are there. So if we know that clear, then it is very easy to solve the problems. Okay. So this concept is basic on understanding, based on understanding. This concept is based on understanding. That's why, so first of all, we have to know what is what. Now, next one is equally likely events. Equally likely events. So, in a random experiment, in a random experiment, in a random experiment, the events are said to be equally likely events if all the events having 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 same number of chances, same number of same number of chances of occurrence. So same number of chances of occurrence. That means if the occurrence of one event not more than the occurrence of any other events in that random experiment. That means all having the same number of chances of occurrence. So then the events are said to be equally likely events. Equally likely events. Next, next classical definition of classical definition of probability. Classical definition of probability. In a random experiments, in a random experiment, in a random experiment, having an mutually exclusive and equally likely events equally likely events. So from this, if m events are events are favorable to the happening, the occurrence, happening or occurrence of an event E out of n events, out of n events, then the probability of E is to be happened is P of E is equal to M upon N. That means number of favorable cases by total number of cases. So that is M upon N. So now probability of E is not to be happened, is not to be happened, is denoted by E bar or E complement. So that is P of E bar is equal to, see here, the probability of is to be happened. So the number of favorable cases in out of n cases, m cases are favorable. So the remaining are unfavorable to the happening of E. What are the remaining here? See here, the total cases are n. So out of n, m are favorable. So m are favorable. So unfavorable cases are n minus m. So number of favorable cases E is not to be happened. This you can simply say that number of unfavorable cases is to be happened by total number of cases. Total number of cases. That means P of E complement or E bar is equal to n minus m by n. So this is E is not to be happened. So P of E, probability of E, m by n. This is E is to be happened. E is to be happened. So from this, see here, from this, P of E bar is equal to n by n minus m by n. So you can split this one, please split this term by, this is nothing but 1 minus m by n. So this is nothing but 1 minus, again m by n means P of E is to be happened. So P of E. So finally we got here, we'll get here P of E bar is equal to 1 minus P of E. So that means P of E bar plus P of E is equal to 1. So finally we can conclude here, total probability of an event is 1. So that means total probability of an event is 1. So total probability must be equal to 1. So see here, m is an integer, n is an integer. See here, so both are positive integers. So both are positive integers. So P of E, so m is less than n or equal to n. So m is less than or equal to n. So sometimes m may be 0 also. So here we have P of E is equal to m by n. So here we have three cases again. M is equal to 0, m less than n, m is equal to n, m is equal to n. So P of E is equal to, so again I am writing here m by n. So here we have three cases. M may be 0, m is less than n, or m is equal to n. So there is no possibility of m greater than n. Why? Because total number of cases is n. So m may be 0 or less than n. M is equal to n. Suppose if m is equal to 0, P of E is equal to 0. P of E is equal to 0. So this is nothing but this is called probability of impossible. Probability of impossible. So m less than n. So m less than n means, see here, m less than n means, see here, so probability of E lies between either 0 and 1. Suppose m less than n. So m less than n means numerator is smaller than denominator. Numerator is smaller than denominator. So we'll get, so the probability lies between 0 and 1. 0 and 1. Suppose if m is equal to n, so P of E is equal to, m is equal to n means probability of event E is 1. That means probability of possible. So probability of possible. That means sure or this case is called sure or certain event. Then in this case, then E is called sure or certain event. So 100% chance, 100% we have 100% chance to happening of E. That is P is equal to 1. So here event of impossible event. Here in this case, In this case, E is called impossible event. So impossible event. Here P is equal to 1, E is called sure, sure event or certain event. So from these three things, we can say that, see here, probability of any individual event either 0 or equal to 1 or lies between 0 and 1. So this is one of the important thing. This is one of the important inequality. So probability of any individual event lies between 0 less than or equal to P of E less than or equal to 1. So either it may be 0 or may be equal to 1 or lies between 0 and 1, but it should not be greater than 1. It should not be negative. It should not be negative. So probability of any individual event should be equal to 0, maybe equal to 0, or maybe equal to 1, or lies between 0 and 1, so that we can define the probability of an individual event like this. So we'll continue the axiomatic remaining topics later in the next class. Okay, till then, bye, have a nice day.